Alright guys, we're going to go over oxidation reduction reactions. I wrote over here on the side a couple of the mnemonic devices. Leo says GR. That means if you lose electrons, you're oxidized. If you gain electrons, you're reduced. The oxidation number is reduced. And oil rig, oxidation is losing electrons. Reduced is gain electrons. So in order to figure out if a reaction is oxidized and reduced, we first have to figure out the oxidation numbers. So we're going to be using basically what we know about oxidation numbers, plus we're going to refer to the oxidation chart over here. So let's go back. So I'm going to start off by this. Now, if an atom is by itself, its oxidation number is 0, so it's only just one atom. Chlorine, I know that chlorine is in column 17, and so there's chlorine right there. It has 3 oxidation number possibilities, but the main one is the -1. And since sodium is a +1, chlorine has to be a -1 because we have to have 1 positive and 1 negative. Or sorry, since iron is positive. So chlorine is a -1 charge here. And there are 2 chlorines, so that means we have a total of a -2 charge, so iron must be a +2 charge here. Alright, so because I have to have enough positive so that when I add that together I get 0 as the sum for the zero-sum rule. Now, sodium now is bonded to chlorine on this side. Chlorine, I just said, is a -1 charge, and so sodium has to be a +1 charge. And iron is now by itself, so it's 0. So let's look at the different atoms and which ones changed. Sodium went from a 0 to a +1. See that? A 0 here to a +1 right here. Okay, and chlorine stayed exactly the same, so I'm not going to worry about that one. But what about iron? Iron went from a +2 charge to a 0 charge. So now I got to figure out which one is oxidized and which one's reduced. Okay, you can see here that the oxidation number of iron went down, and when the oxidation number goes down, it's reduced, and that makes sense to me. So when the oxidation number goes down, the element is reduced. So iron is reduced. And if you're reduced, you have to gain electrons. So it did gain electrons. How many electrons did it gain? Okay, if I have to go from a +2 to a 0 charge, it gained 2 electrons. 2 electrons. Now, sodium is oxidized because if it's not reduced, then it's oxidized. And when you're oxidized, you lose electrons. So sodium went from a 0 to a +1. So let's think about that mathematically. If I go from a 0 to a +1, then I have to subtract out one of the electrons. When you subtract 1 electron, you go to a +1. So sodium went from a 0 to a +1, but there are 2 sodium atoms. Okay, so even though one atom just is going to lose 1 electron, okay, it's going to lose one electron. Since there are 2 atoms, we lose 2 electrons. And so those 2 electrons left the sodium and went into the iron. So sodium is oxidized. Iron is reduced. Now, which one are the oxidizing agent? This is just easy. If sodium is oxidized, that means it gave up electrons, and those electrons are going to be used to reduce the iron. And since there's 2 sodium atoms, it'd be twice as many electrons it's going to give up. So if it's oxidized, it is the reducing agent. If it's reduced, it's the oxidizing agent. Okay, all right, let's try another one. We have here, this is, what is this molecule? C, double bonded C. Okay, this is ethene. Ethene, okay. I'm going to take ethene and I'm going to figure out what happened. All right, I know that I have oxygen here with a 0 charge because it's all by itself. Okay. Now you can see oxygen shows up in more than one spot, so it's possible for oxygen to have more than one oxidation number over here. I know that hydrogen is a +1 charge unless it's bonded to a metal, and carbon is a non-metal. So hydrogen is still a +1 charge. All right? But there are 2 of them, so that's that +2 total. Okay? So if hydrogen is +1 and we have a +2 total charge, then what charge is carbon? Okay? Well, let's go back up here and look at the chart. Carbon can be a 4, a -4, or a 2. A 4, a -4, or a 2. All right. So it looks like this is going to be one of the exceptions to the rule, because hydrogen can be a +1 or a -1. I have a +2 charge over here. Hydrogen is not bonded to a metal, so carbon has to be actually, in this case, a -1. It's an exception to the rule. Okay? All right, because there's 2 of them, and that would be the -2 charge. That's how they cancel each other out. Now let's look at the other side. Oxygen is usually a -2. And since I have 2 of them, that would be a -4 charge. And since I have 1 carbon, it has to be a +4 charge. All right, that makes sense because carbon went from a -1 to a 4, and oxygen is going from a 0 to a -2. So one is getting bigger or one's getting smaller. You always have to have one oxidized, and one's reduced. What about over here? Hydrogen is a +1 charge. There are 2 of them. That makes a +2. We'll see hydrogen is a +2 over here. I mean a +1 over here. And is a +1 over there. So it didn't change. All right. Now what about oxygen? Oxygen is still a -2 charge right here. So oxygen still went down by -2. So let's look at which one did which. Carbon goes from a -1 charge to a +4 charge. And oxygen goes from a 0 to a -2. So which one is reduced? That's the one I always look at first. Which one goes down? Well, oxygen went down. Okay? Oxygen went down. It went from a +0, I mean not a positive, it went from a 0 to a -2. So this is reduced. And how did it get reduced? It had to gain electrons. So it gained, each oxygen atom gained 2 electrons. Okay, so if that one's reduced, this one has to be oxidized. And how did it get oxidized? Well, we went from a -1 to a +4. So -1, if it's oxidized, it's going to lose electrons. -1, subtract out some amount of electrons, has it got to equal a +4. Well, that has to be 5 electrons. 5 electrons, because a -1 plus 5 would equal a +4. So if you subtract 5 electrons, so to be oxidized, I had to lose 5 electrons over here. Okay? So if this one is reduced, it is the oxidizing agent. And if this one is oxidized, it is the reducing agent. Now remember that being oxidized means it caused the other guy to be reduced. It's the reducing agent. Being reduced means it causes the other guy to be oxidized. It's the oxidizing agent. All right, I'm going to do just one more. I think I'll do number 6, and we're going to look these guys up. All right, let's look up silver. Ag. Silver has a +1 charge. Okay, so I'm going to go back over here. This would be a +1 charge. Whoops, a +1 charge. And since silver's by itself over here, it has a 0 charge, a 0 oxidation number. What about nitrogen? Okay. Nitrogen has a 3, a -3, or a 5. So let's keep that in mind. A 3, a -3, or a 5. So I'm not sure which one to use yet. So for nitrogen, we're going to write down here, it could be a 3, a -3, or a 5. Well, what about oxygen? Well, oxygen is always a -2, or almost always a -2. So I'm going to figure out what nitrogen is based on this. I have 1 + 1 for the silver. I have 3 -2s for the oxygen. So -2 times 3 is a -6. I know when I add it all together, it's got to equal 0. So what does nitrogen have to be? Well, it looks like nitrogen has to be a +5. Okay, hopefully y'all understand what I just did. Silver is a +1, oxygen is a -2. There are 3 oxygen atoms. -2 times 3 is a -6. When I add it all together, it has to equal 0 because of the zero sum rule. So nitrogen, since there's only one of them, has to be a +5 so that when I add that together, I get 0. So there's my oxidation states in the silver nitrate. Copper right here is all by itself, so that's a 0. All right, now we come back over here. Let's look up copper again. Here, copper is a +2 or a +1 right there. A +2 or a +1. All right, so let's go over here and see what that would mean. Copper has to be a 2 or a 1. Now notice this nitrate is the same as this one over here. We have oxygen as a -2, and so that's a -6 charge. And when I add this all together, it's got to equal 0. If nitrogen is most likely a +5, because it's still nitrate, it's still the same polyatomic ion. So nitrogen is a +5. So that's a +5 charge. So which one of these charges will work? If I have a +5 and a -6, then it looks like copper has to be +1. Okay? Now, the reason I figured that out is because this is nitrate and this is nitrate. It's identical polyatomic ion. So here I figured out nitrogen is a +5, so this nitrogen has to be a +5, and so does this oxygen's a -2. All right, that makes copper, the only thing it can be is a +1. Now I see all my changes. So the silver goes from a +1 charge to a 0. The copper goes from a 0 charge to a +1. Nitrogen stayed the same and oxygen stayed the same. So these are the ones that are oxidized and reduced. Which one is reduced? That's the first question I always ask. Which one goes down? Copper. Copper went down. So this is reduced. And it gained. No, this is not reduced. Silver is reduced. Whoops. Let's erase that. Silver is the one that went down. It went from a +1 to 0. That's reduced. So this is reduced. And it gained 1 electron. Copper then is oxidized. And it lost 1 electron. So silver is the oxidizing agent. And copper is the reducing agent. Now, I may ask you a question. I give you a reaction and ask you, is it a redox reaction? The only way to know is if you go through this process to determine all the oxidation numbers. And if you see this oxidation number change from left to right, from reactants to products, then you have a redox reaction. If the oxidation numbers stay identical, you do not have a redox reaction. So you must notice a change. And remember again, Leo says grr. Lose electrons, oxidized. Okay, oxidized, lost electrons. Gain electrons, reduced. Reduced, so I gained electrons. Okay, or oil rig. Oxidized is losing. Oxidized is losing electrons. Reduced is gaining. Reduced, gained electrons. Okay, I hope that will help you.